Okay, so example 6, and I know in the last video I said I was going to do an initial value problem. I promise I will. I just realized I haven't done a repeated root one, which is using theorem 6, and actually the book uses a lot of uh, solutions with distinct roots, and the repeated roots will. I mean, we're going to keep seeing that, but it wasn't very many examples, but I did want to do one of a repeated root, so you know, I mean, I have used state theorem 6, but if you're not using it, then yeah. Okay, so 6, and I want to choose 9y double prime plus, that's a 12y prime plus 4y equals 0. Okay, so I want to find the general solution to this differential equation. So can we, well, we're going to use, again, our, let me go ahead and just switch to white. What's our characteristic equation? Okay, it's going to be 9r squared plus 12r plus 4 equals 0. Here there's no greatest common factor. But we can factor, this is actually one of the perfect square trinomials in algebra. This is actually, so 3r times 3r is 9r squared, and obviously 2 times 2 is 4, and plus plus. But notice that, I mean, these guys are the same factor. You're repeating the same, I mean, if you want, you can write it a little more succinctly like this, and then take the square root of both sides. But I mean, here we can see that 3r plus 2 is going to be 0. You don't have to write the other factor again because it's just a repetition. 3r equals negative 2. Therefore, r is negative 2/3. So again, this is my r1, but it's really the same thing as your other r2. Okay, so now using theorem 6, your solution, and let me just go ahead and write exactly what the book does so I can refer to it. So they have C1 plus C2 x times e to the r1x. Okay, this is fine. I'm going to go ahead and distribute this guy because it's going to be very helpful in understanding why we have the solution. So C1e to the r1x plus C2xe to the r1x. Okay, all I did was just distributive property from algebra. Okay, so now let's insert our R1 and R2, which are really the same. So C1e, okay, what's my R1? Well, it was negative 2/3 x plus C2 x e to the negative 2/3 x. Okay, so this is our general solution, but what I want you to notice is, let me get my pointer here. Okay, so you have these coefficients, right, which we're going to find them later. And then you have e to the negative 2/3 x here, and then you have it here. But you notice there we've inserted a factor of x here. Now, the reason is because we need these two solutions have to be linearly independent solutions. So if we have a factor of x, if we multiply by a factor of x here, then that's going to make it linearly independent. That's why I mean, I can prove this to you, or you can look at it in the book, but if we don't write this x in here, then they're going to be linearly dependent, and we don't want them to be linearly dependent. They need to be independent solutions. You can write it like this, but I've noticed that some of the book the solutions do write it like this. They just distribute that e to the r1x. So again, the repeated solution, again, if you have a root that's repeated, you're going to use theorem 6 instead of 5. Okay, initial value problem coming up, I promise.